Okay, guys, so this is test number 4 review. Here I'm going over the problems which I sent you a week ago for the review. So I list the problem from page 950 from your textbook in 951. And I will go over some of them. So let's talk about number 1. Number 1, for the rational expression t minus 2 over t plus 9, they're asking a couple things. A, you need to evaluate the expression if possible. So evaluate the expression, of course, if possible, and they give you t equal 0, 1, 2, -3, -9, and that's it. Okay, so I'm just going to do a couple of them. Okay, when t is equal 0, you're going to plug in 0 for t. So we'll have 0 minus 2 over 0 plus 9, and we're getting -2 over 9. Okay, let's say when t is going to be equal to, you're going to do the same thing. You're going to replace t with 2. So we're having 2 minus 2 over 2 plus 9, and we're getting 0 divided by 11, which is 0. And I will do one more. When t is equal -9, I'm plugging in -9 for t. So we have -9 minus 2 over -9 plus 9. Okay, so we're getting -11 over 0, and this is undefined. Okay, so it's undefined when t is equal -9. Why? Because t equal -9, when something is undefined, it's the restricted value. Okay, so that was part A. For B, I just did that. They asking you to identify the restricted value. So the restricted value is the value for which the equation can be solved. So like you see, when t was equal -9, we were not able to solve that. We end up with -11 over 0, which is undefined. So t equal -9 is restricted value. And another way to find the restricted value, you will go back to your original rational equation. You take the denominator. So another way, you take denominator and you make that equal 0 and you solve the equation. So denominator was t plus 9. If you make that equal 0, you'll end up with t equal -9, which is the restricted value. Okay, so again, to find the restricted values, denominator equals 0. This is what you do. So that was number 1. Number 3. Let's see number 3. Which of the rational expressions are equal? So you have 3a, you have 2 minus x over x minus 2. B, you have x minus 5 over x plus 5. C is -x minus 7 over x plus 7. And D, we have x squared minus 4 over 4 minus x squared. So technically what they want you to do, they want you to factor them so you can see which are equal. So here what I'm going to do with A, I going to factor -1. So if you factor -1, negative x become positive x, and that positive 2 will become -2. And then on the bottom, I have that x minus 2. And when you cancel them, because they are the same, you end up with -1. So I know A is technically -1, okay? So I think C is very similar to what we had in A. So I will try to use the same thing in C. I will factor -1 from numerator so that negative x become positive x, and that -7 become positive 7. So when you factor -1, your original operation sign changed to opposite. And on the bottom you have x plus 7. They will cancel and we end up with -1. So A and C definitely are equivalent because they both equal to -1. So let's see what else. So let me move on to D. D, I'm going to factor. So x squared minus 4 is the same, let's do that in orange, as x squared minus 2 squared, and this is a difference of square formula. You can factor this as x minus 2 times x plus 2. Okay, and on the bottom, what I'm going to do, you have 4 minus x squared, which is the same as 2 squared minus x squared. So you can factor this, and that will give you 2 minus x times 2 plus x. So look what happened. 2 plus x is the same as x plus 2. That will cancel. So let's start simplifying this one. So we end up with x minus 2 over 2 minus x. So look what happened. They are opposite. This x is positive, this one it's negative. This -2 on the top, it's negative. 2 on the bottom, it's positive. So they are opposite, so that means the answer will be equal -1. But to see that better, I'm going to factor -1 from numerator. So -2 become +2, and this positive x will become negative x. And here we have 2 minus x, and we end up with -1. Okay, so A, C, and D are equivalent because you can simplify them, and all the time you're getting -1. Let's check what happened with B. So with B, I will try to do the same thing. I will try to factor -1 from numerator. So this x will become -x. That -5 will become +5 over x plus 5. However, here we don't have the same expression in the parentheses, so we can't cancel. So B, it's different. So A, C, D are equivalent because we were able to factor them and we were able to get -1. Okay, next one, it's number 5. From the review, in number 5, identify the restricted value. So we have h plus 7 over 3h plus 1 times h plus 7. So again, don't forget that I'm solving the problems from the review exercise. That's the review exercise from page 950, 955. Okay, so you have review exercise. Okay. So find the restricted value. I told you before that to find the restricted value, you take your denominator and you make it equal 0. So we take denominator, make it equal 0. So we have 3h plus 1 times h plus 7 equals 0. Since you have a product and two factors, you're solving two equations. 3h plus 1 equals 0. H plus 7 equals 0. Here we're getting h equal -7. Here we'll get that h is equal -1 over 3. So -1/3, -7 are the restricted values. Okay, that was 5. We're moving on to 7. In number 7, they also want you to find the restricted value. So we have 2w squared plus 11w plus 12 over w squared minus w squared minus 16. Okay, so I saw it. Okay, we have to identify here, number 5, identify the restricted value, and they also say, and simplify. Okay, and they ask you to simplify. So here to simplify, so look what happened. We have x plus 7 on the top, x plus 7 on the bottom. That will give you 1/3h plus 1. So they're asking for both, for identify the restricted value and simplify also. Okay, so in number 7, I'm going to start with restricted value. Restricted values. So that's the values for which equation doesn't make sense. You take your denominator and make it equal 0. So we have w squared minus 16 equals 0. Okay, I'm going to factor this using a squared minus b squared formula, which is the same as a minus b times a plus b. So that will become w squared minus 4 squared, which is w minus 4 times w plus 4, and that has to be equal 0. So when you have product of two factors, you're solving two equations. W minus 4 equals 0, and solve w plus 4 equals 0. So w is equal 4, w is equal -4. So those two are restricted values. Okay, and next one, what they want you to do, they want you to simplify. Next one, they want you to simplify. So simplify. Okay, so we have numerator, which is 2w squared plus 11w plus 12. What you guys need to do, you need to factor numerator using AC method. Because to simplify, you want to cancel repeating factors. So we need to factor this. Okay, so we need to rewrite that as a product of two factors. So A is equal to, B is equal 11, C is equal 12. So we multiply A times C, and we're getting 2 times 12, which is 24. Next, we're looking for two numbers, which by multiplication gives you AC, which is 24, and the same two numbers, which by addition gives you B, and B is equal 11. So what's going to work here? We have 24, 8 times 3. 8, 3, 8 plus 3, it's 11. 8 times 3. So now you guys have to remember that, look what happened. A is equal to, so what I'm going to do, I'm building two parentheses, and I'm putting 2 in each. So I have 2w plus 8 times 2w plus 3. And then when you build them, when you have that leading coefficient different than 1, you have to remember that you need to factor GCF. So 2w plus 8, the GCF is 2. So we're factoring 2 and we end up with w plus 4. And don't forget that you ignore that GCF. So you only keep w plus 4. Okay? And the second parenthesis, which is 2w plus 3, since there's nothing to factor, so GCF is equal 1, we're going to keep it 2w plus 3. So our second factor will be 2w plus 3. So when you factor quadratic equation, when the leading coefficient is different than 1, so usually that 2, which is a, it's only you only see that in one parenthesis. So now we're ready to simplify. Okay, so we factor numerator, and our numerator it's equal to w plus 4 times 2w plus 3. I factored the denominator before, which is w minus 4 times w plus 4. And to simplify, you see that w plus 4 repeats. So we end up with 2w plus 3 over w minus 4. So this is the simplified form. Okay, so number 7, they ask you for two things. They ask you to find the restricted value. I took the denominator, I factored the denominator, and I make each factor equal 0, and I end up with two restricted value. And then they want you to simplify this rational expression, which means you need to factor numerator, and you need to factor denominator, and then cancel repeating factors. 713. Let's talk about number 13. Number 13. So in number 13, they asking for the same thing. You have p plus 7 over p squared plus 14p plus 49. Okay, so find restricted values. So to find the restricted values, you take the denominator, which is p squared plus 14p plus 49, and you make it equal 0. Since this is quadratic, you need to factor. So I'm using AC method. A is equal 1, B is equal 14, C is equal 49. Find two integers which by multiplication it's equal A times C, which is 49. And the same two integers by addition it's equal to B, which is 14. So 7 and 7 will work. 7 times 7, 49. 7 plus 7, it's 14. So we can rewrite that p squared plus 14p plus 49. We can rewrite this using the factors. P plus 7 times p plus 7. And now to find the restricted values, make that equal 0. Okay, so take each factor and make it equal 0. And we're getting p equal negative 7, p equal negative 7, since we have the same restricted value. So we're just writing this once. Restricted value is p equal negative 7. Okay, and the second part is to simplify this expression. So factor numerator, since it's prime, you're just going to copy p plus 7. Then factor denominator, we end up with p plus 7 times p plus 7. and just cancel repeating factor, which is p plus 7. And that will give us 1 over p plus 7. Okay, so that's the simplified form of the given rational expression. Okay, so that was number 13. I'm moving to number 17. Number 17. In number 17, multiply or divide. Okay, so 17 we have 8 over x squared minus 25 times 3x plus 15 over 16. Okay, so how you guys going to multiply? Okay, so we multiply numerator with numerator, denominator with denominator. So we have 8 times 3x plus 15 over x squared minus 25 times 16. So this is how you multiply fractions. But again, to simplify them, you need to factor each. Okay, so we need to factor each. 8 is the same as 4 times 2. I'll just keep it as 8. I'm just going to leave it as 8. Let's talk about 16. Let's talk about 16 right here. Again, 16 is the same as 8 times 2. So I'm going to rewrite 16 as 8 times 2. Now the expression 3x plus 15, 3x plus 15, what you can factor GCF, greatest factor, which is 3. So factor 3, so we end up with 3 times x plus 5. And x squared minus 25, I'm going to factor as x squared minus 5 squared. So this is the difference of square formula, x minus 5 times x plus 5. So let me rewrite everything using factors. Okay, 8 is 8 times 3x plus 15, which is the same as 3 times x plus 5 over x squared minus 25 is the same as x minus 5 times x plus 5. And 16 is the same as 2 times 8. And now we canceling the repeating factors. 8 will be cancelled, x plus 5 will cancel, and technically that's it. So the final answer will be 3 over 2 times x minus 5. And that's the final solution. Okay, so that was number 17. Let's do number 19. Number 19, the same thing, multiply or divide. So we have q squared minus 5q plus 6 over 2q plus 4 divide 2q minus 6 over q plus 2. So you have fraction divide by fraction. So we don't forget the shortcut keep change flip. Keep the first fraction, which is q squared minus 5q plus 6 over 2q plus 4. Change division to multiplication and flip over the second fraction. So that will be q plus 2 times 2q minus 6. So now what we're going to do, we're going to multiply. And the way we multiply numerators together and denominators together. So we end up with q squared minus 5q plus 6 times q plus 2 over 2q plus 4 times 2q minus 6. And now to simplify, you need to factor out each of the expression in the parentheses. So let me start with factoring q squared minus 5q plus 6. So factor q squared minus 5q plus 6. And again, that will be q and q plus something and minus something. So how are we going to do it? A is equal 1, B is equal negative 5, C is equal 6. I'm using AC method for factoring. So A times C is equal 1 times 6, which is 6. I'm looking for integers, which by multiplication gives you AC, which is 6. And the same two integers by addition gives you B, which is negative 5. So what's going to work? Negative 2 and negative 3. So that will be q, when you factor q minus 2, q minus 3. Okay, so I'm going to copy this down. My q squared minus 5q plus 6 is the same as q minus 2 times q minus 3. Now this one, q plus 2, it's prime, so I'm going to copy this down. There's no way that I can factor this. Okay, now next what I'm going to do, I'm going to factor 2q plus 4. So here you can factor GCF, which is 2. So I'm factoring 2 out, and we end up with q plus 2. So 2q plus 4 is the same as 2 times q plus 2. And last thing what I'm going to do, I will factor 2q minus 6. So factor 2q minus 6. So find the GCF, which is also 2, and factor 2 out. So 2q divided by 2 will give you q. Negative 6 divided by 2 will give you negative 3. So we end up with 2 times q minus 3. Okay, and now when you factor everything completely, you're ready to start canceling. Q minus 2 is just once. Q minus 3 cancel. Then q plus 2 and q plus 2 cancel, and technically that's it. So we end up with q minus 2 over 2 times 2, which is 4. So this is our final answer. So I multiply numerators together, and of course then I factor everything completely. So that's the key. Okay, it was division originally, so when you have a division, don't forget about shortcut keep change flip. Keep the first one, change division to multiplication, flip the second fraction. Okay, next one is number 23 of the review. So number 23, boom, boom, boom. Okay, fraction divide by fraction. Okay, so you have n squared plus n plus 1 over n squared minus 4 over n squared plus n plus 1 over n plus 2. So first I'm going to apply keep change flip because you have fraction divide by fraction. Okay, keep the first fraction. Again, don't forget that your major operation, it's right here in the middle, division. So I'm going to rewrite this as n squared plus n plus 1 over n squared minus 4. Then change will be change division to multiplication, okay? And flip will be flip this fraction. So n plus 2 goes on the top, and n squared plus n plus 1 goes on the bottom. And now we're going to multiply, and multiplication is always easier than division. Okay, so fraction multiplied by fraction, you multiply numerator by numerator. So we're having n squared plus n plus 1 times n plus 2, and multiply the denominators together. So we have n squared minus 4 times n squared plus n plus 1. And look what happened now. We actually can cancel those two parentheses because they are exactly the same. So we're going to rewrite this as n plus 2 over n squared minus 4. And let's factor now n squared minus 4. So factor n squared minus 4. So I'm using here the formula a squared minus b squared, which by now everybody knows. A minus b times a plus b. So in our case, we having n squared minus 2 squared, which will be n minus 2 times n plus 2. So on the bottom, we have n minus 2 times n plus 2. And on the top, we have n plus 2. And now we can cancel n plus 2 because they are the same. So that will give us 1 over n minus 2. Okay, that's the final answer. Okay, that was number 23. Next one, it's number 29. Here, determine the LCD. So you need to find least common divisor. And the expression is, they give you two expressions, 8 over m squared minus 16. And the second expression is 7 m squared minus m minus 12. So I gave you all the steps how to find the LCD. So first, what you guys need to do, you need to factor each denominator. So m squared minus 16 is the same as m squared minus 4 squared, which is the same as m minus 4 times m plus 4. Now, this denominator is quadratic, so we need to factor quadratic. M squared minus m minus 12, you need to rewrite as m times m and something in a parenthesis. So a is equal 1, b is equal negative 1, c is equal negative 12. So to factor that AC method, a times c is equal negative 12. Find two integers, which by multiplication will give you AC, which is negative 12. And the same two integers, by addition, has to give you B, which is negative 1. So we have to check what will work. Negative 4 and 3 will work. Negative 4 times 3, negative 12, negative 4 plus 3, negative 1. So to factor this, we have m minus 4 times m plus 3. So now we have to find LCD. So find LCD, you taking your denominators which you factor. So m squared minus 16, you're going to rewrite as m minus 4 times m plus 4 of m minus 4 times m plus 4. And the second denominator which we factor, m squared minus m minus 12, which is the same as m minus 4 times m plus 3. So since all of those factors are unique, we're going to multiply them together. Is m minus 4. Repeats only once. And repeats here. I'm sorry. So I have it. Times m plus 4. And so I have this one. And of course, you cannot leave the missing factor, the remaining factor. So we have to multiply times m plus 3. So this is LCD. That's the solution. I factor both, and to find the least common divisor, the idea is to factor completely each denominator. If factors repeats, you're going to copy that factor to the highest exponent, and the one which are unique, you multiply them. So you cannot ignore them, you cannot skip them. That was number 29. 35. Next it's 35. I think I'll have to create 2 videos for the review. So 35, what they ask in 35, write each fraction as equivalent fraction with the LCD as its denominator. So 35, they give you fraction 5 over AB to the third power. And the second fraction, they give you 3 over AC squared. So first what we need to do, we need to find LCD. Least common divisor of our divisors. So of AB to the third power and AC squared. So LCD equal. Okay, so we taking A, we have A and A, they both to the first power, so we copy A. So we have them. Then we have B. Since it's only one B, so we copy the B the way it is, B to the third power, times remaining times the remaining factors, which is C squared. Okay, so A, B, Q, C squared, that's the LCD. So now what you need to do, you take your original fraction, and we did problems like this, 5 over A, B to the third power, and you need to rewrite it as an equivalent fraction where the denominator is LCD, which is A, B cubed, C squared. So look what happened. Our original fraction has A already and has B already, B to the third power. So we're missing C squared. That means we're going to multiply top and bottom by C squared. And the equivalent fraction will be 5C squared over AB cubed C squared. Again, they're not really canceling here. I was just trying to show you that we multiply the original fraction by the missing factor from LCD. Okay, that's what we did. Now, you take the second fraction, this one, 3 over AC squared, and you build equivalent fraction with denominator being equal to LCD, which is AB cubed C squared. So you multiply your original fraction by the missing factor from LCD. So I have A, I have c squared, so I have a, I have c squared, so the missing factor is b to the third power, so I multiply top and bottom by b to the third power. And that will give you 3b cubed over ab to the third power c squared. Okay. Okay, so that was number 35. Next one, 37. So 37 is the same type of problem. So again, hopefully when you guys review, you have your ebook in front of you. So 37, write each fraction as equivalent fraction with the LCD as a denominator. So they give you two fractions, 6 over q, and they give you 1 over q plus 8. Okay, so first I need to find the LCD of denominators of q and q plus 8. Since both of them you can't factor because they are prime, so the LCD will be, just multiply them, q times q plus 8, and just keep it as a product. Okay, so now we build equivalent fraction. So 6 over q, okay, we need to build the fraction which has denominator equal to q times q plus 8. So the same idea, since original fraction had q already, so I'm missing q plus 8. So I multiply top and bottom by q plus 8. So now numerator times, then we have 6 times q plus 8 over q times q plus 8. And numerator, you can just distribute that 6 to both. So that will give you 6q plus 48 over q times q plus 8. So 6q, again, 6q is the same as this. Okay, we built equivalent fraction. Now I'm taking 1 over q plus 8. Now I'm taking that second fraction, 1 over q plus 8. And I'm building equivalent fraction with denominator equal to LCD, which is q times q plus 8. So my original fraction has q plus 8. So I'm multiplying top and bottom by the missing factor, which is q. So we're getting 1 times q over q plus 8 times q, which we have. And that will give you q over q times q plus 8. And again, you don't cancel anything here because they want you to build that equivalent fraction. So we keep it that way. So that was number 37. Next one will be 41. In 41, add, subtract. So we need to add it. We have x squared over x plus 7 minus 49 over x plus 7. So you're adding fractions. In this example, since both fractions have the same denominator, so we don't do anything, we just copy denominator once, which is x plus 7, and we subtract numerators. So that will be x squared minus 49. So when you're solving those type of problems, you always want to simplify completely. So hopefully you guys see that your numerator is x squared minus 49. You can factor this. This is the same as x squared minus 7 squared. So use the formula a squared minus b squared, which is a minus b times a plus b. and that will give you x minus 7 times x plus 7. So I'm going to factor that numerator. We did that, and rewrite this as x plus x minus 7 times x plus 7. And on the bottom you have x plus 7, and look what happened. X plus 7 repeats, so we're going to cancel, and that will give us x minus 7. So the final solution which you should put on the test should be x minus 7. So you always simplify. 41, 45, it's next. So for 45, it's the same set of problems. So you need to subtract. You have 5 over 45, 5 over 2r plus 12 minus 1 over r. Okay. So here, guys, on the review, like you see, I'm not giving you steps because I gave you all the steps during the videos when I introduce every single problem. So now I'm just reviewing for you. So to be able to subtract the fractions, you need the same common denominator. So what you need to do, you need to find LCD first of two denominators, and then rewrite each fraction as an equivalent fraction using denominator, which is LCD. So first, what I'm going to do, I'm going to factor each denominator. So we have 2r plus 12. You're going to factor 2 out, which is GCF, and we end up with r plus 6. R is prime, so r is r. Okay. So keep r. So now what you need to do, find least common divisor from 2r plus 12, which is the same as 2 times r plus 6 and r. Okay, so your LCD, it's going to be each factor. So we're going to have a 2 times r plus 6 times r. Since all of them are unique, you're going to multiply them together. Next, what you're going to do, build equivalent fraction. Using LCD as a new denominator. And again, if you guys struggle with that, this is section 15.4. You can watch the lecture if you didn't watch it yet. Okay, so the first fraction, which is 5 over 2r plus 12, which is the same as 5 over 2 times r plus 6, because we factor that, you need to build equivalent fraction, which has denominator, which is LCD, 2 r plus 6 times r. So my original fraction has 2 and has r plus 6. So the only thing which is missing is r. So I multiply top and bottom by r. And we end up with 5r. Okay. So I'm going back to this problem. And 5 over 2r plus 12, I'm going to rewrite as 5r over 2 times r plus 6 times r. Okay. Then I copy this minus. And the next fraction, which is 1 over r, I need to create equivalent fraction, which has denominator, which is LCD, which is 2 times r plus 6 times r. So original fraction half r, okay? So what is missing? The missing is 2 times r plus 6. So we multiply that bottom by 2 times r plus 6. So we have our denominator, which is already ready. Here we multiply. So we're getting 1 times 2 times r plus 6, which is the same as 2 times r plus 6 over 2 times r plus 6 times r. So that's the equivalent to 1 over r. So I'm going to replace 1 over r with 2 times r plus 6 over 2 times r plus 6 times r. Okay. And now we're ready to subtract them. So we have the same denominator. So you copy denominator, which is 2 times r plus 6 times r. And you subtract the numerators. So you have 5r minus 2r plus 6. So now when you simplify, here I want you to distribute negative 2 to both. So that will give you 5r minus 2r minus 12 over 2 times r plus 6 times r. And that will give us 5r minus 2r, which is the same as 3r minus 12 over 2 times r plus 6 times r. And don't stop yet. Your numerator here, you can factor 3 out. So when you factor 3, we end up with r minus... No, don't factor 3. Sorry, it's a long video. So we want to cancel that r plus 6. To get 6 from 12, it makes sense to factor... It will make sense to factor 2, but it won't work. Did I mess up with this problem? Can we simplify? 45. No, it's correct. So we're going to factor 3. Okay, there's nothing else what I can factor. Factor GCF. So when we factor 3, we end up with 3 times r minus 4 over 2r. So 2 times r, I'm just going to copy as 2r, r plus 6, and that's it. There's nothing really what we can do. And simplify. So that was a long one. That was number 45. I'm going to stop here, and the remaining problems I'm going to record in the second video.